histogram of this data set. For example, you can see the lifetime in hours, 300 to 400, 400 to 500, 500. You can also see the number of laps that is there: 14, 56, 60, 86, 74, 62, 48. We are asked to create the histogram for this data set. So this is the histogram here. As you can see from here now, the highest number of laps is 86, that is 600 to 700. Check the longest bar here. The longest bar and the data set, the lifetime in hours is 600 to 700. That is the variable with the highest frequency. That means in the range of 600 to 700, that's about that's that about. Move to the other one, but the bar chart. Let's move to the bar chart. So bar charts can also be called bar graph. They are diagrammatical or pictorial representation of data in the form of vertical or horizontal bars, where the length of the bars, like histogram too, the length of the bar is proportional to the frequency of the data. So for a bar chart or a bar graph, it has three major attributes. And these three major attributes of a bar chart are: the bar chart helps us to compare the different set of data among different groups easily. It also shows the relationship using two axes, in which the categories on one axis and the discrete values are on the other axis. It also shows the period of time. For example, now let me show you. This example. In a firm of 400 employees, the percentage of monthly salary saved by each employee is given in the following. So it is comparing the savings in percentage of the number of employees. So how many employees saved 20% of their salary this month? How many people saved 30% of their salary this month? How many people saved 40 people? So this table shows us that this is it. So this particular table shows us the savings in percentage and the number of employee. Okay, I'm coming. Can you all see my screen well now? So let us continue. So in a firm of 400 employees, the percentage of monthly salary saved by each employee is given in this table. So we can represent this frequency table on a bar chart. So this is how to the steps in drawing a bar chart. So for example now, let us have different types of pets. We have numbers. We have 22 cats, 39 dogs, 5 rabbits, and 9 hamsters. So the first step is to decide the title of the bar chart. The title of the bar chart. For example, now we can give this one title: number of pets. number of pets in the household. So the step two is draw the horizontal axis and the vertical axis. So you can draw the types of pets on the vertical axis, or the types of pet on the vertical axis, and the number of pets on the horizontal axis, and you now label it. That is, you number it: the cats, the dogs, rabbit, and hamster. You So you now finalize the scale range for the given data, and then you draw the bar chart that should represent each category of the pet with their respective numbers. So that is what I do with this table here. For the 105 employees saved 20% of their salary. 199 percentage 199 employees save 30% of their savings of their salary. So this is the bar chart here. This is the bar chart. This is it. 105 saved 20%. 199 saved 30%. So this is the number that saved 40%. So the highest percentage is 30%. So 199 people saved 30%. So the frequency can be 30% because it has the longest bar. Can you see? So let's move to the next one. So differences between bar chart and histogram. So the bar chart and histogram look similar, as you can see, but one of the obvious difference there is that in histogram, the bars are close to each other. They are not separated. But in bar chart, there are spaces. Bar chart, there are spaces in between. That in bar chart we plot discrete data, and in histogram plots continuous data. For example, if we have different breeds, types of TV programs, so the best we should use for this is the bar chart. So it compares the things among different groups. So, but if we have continuous data like weight of people, height, and so on, so the best choice is the histogram. So these are the major differences between the bar chart and the histogram. So the next one is the pie chart. The next one is the bar chart. What is a pie chart? Pie chart. The pie chart is also known as a circle chart, dividing the circular statistical graphic into sectors or sessions to illustrate the numerical problems. So it is a circle chart. So the data are represented in a circle, and they are separated into sectors or sessions. So to find out the composition of something, pie chart works the best at that times. In most cases, pie charts replace other graphs like the bar charts, the line plot, histogram, and so on. So the pie chart is an important type of data representation. It contains different segments and sectors in which each segment and sector of a pie chart forms a specific portion of the total percentage. As you can see, for a circle, the total degree for a circle is 360 degree. So the sum of all data in a pie chart, because it is a circle, it is also 360 degree, and the total value of the pie is 100%. So this is how to work out the percentage for a pie chart. So you categorize the data. There's an example here. There's an example here, I'll give it to you. Calculate the total, divide the categories, then convert into percentage. And finally, to data 60-degree. Given data divided by the total value of data times 360-degree. For example now, let's say total value of the data is let's say it is 300, and a particular data is 30 out of that 300. So to calculate the angle for that session, for that sector, we say 30 divided by 300 times 360-degree. 30 divided by 300 times 360-degree. So we have 36 degree. So we cut out 36-degree from a whole circle, from a complete circle for that data. So this is an example of a pie chart. This is an example of a pie chart. As you can see, this physics takes 23%, 20%, 9%. If you calculate everything, 23 plus 20 plus 9 plus 11 plus 24 plus 13, everything should give you 100%. 100%, everything should give you 100%. So that is that concerning the pie charts. So the box plot. So let's go to box plot. Also known as the box plot is also known as the box and whisker plot. The box plot is also known as a box and whisker plot. It is a graphical representation used in statistics to display the distribution of a data set. So this box plot, we can also call it 5-number summary, because it takes the only thing we need to draw a box plot is the 5-number summaries, is the data's minimum, that is the smallest frequency, the Q1, the first quartile, also the second quartile, the third quartile, and the maximum value. So these are the values we need for box plots. So these are the part of box plot: the outliers, the minimum, the median, maximum, and the interquartile range. So these are different parts of box plot. Let me explain it one by one. So the minimum is the smallest value in the given data set. The minimum is like the minimum value in the given data set. The first quartile is the first quartile. The Q1 is the median of the data set. So you separate the data into two. The first half, you find the median of the first half. That is your first quartile. And the median is the middle number, the middle value of the given data set that separates or divides the data set into two equal parts. The median is the middle value which separates the given data set into two equal parts. It is also considered the median of the second half of the data. Let's say when you share the data into two, and the median of the first half is the first quartile. The median of the second half is the third quartile, and the maximum is the highest value given in the data set. The maximum is the highest value given in this data set. So apart from these 5 terms, so the other terms that are used in the box plot are the interquartile range and the outlier. So the interquartile range is the third quartile minus the first quartile. It is the difference between the third quartile and the first quartile. That is what we known as the interquartile range. And the outlier, the data that falls on the far left or right side or of the other data is tested to be the outliers. So generally the outliers fall more than the specified distance from the first and third quartiles. As you can see, these are what you call the data that fall at this side. The like let me say the terminal end of the data set are what we call the outliers. So that is that about box plots. So now let's move to our second our second topic for today, which is introduction to probability. So we'll be discussing what probability is, the basic concepts we use in probability, and basic concepts we use in probability. We explain what we mean by the independent and the dependent events. Then we solve simple questions in probability. So that is that about probability. That is what we are covering. So for the definition of probability, everyone knows that. So people define probability as a game of chance. We define probability as a game of chance. Yeah, I define my probability as the measure of likelihood of an event to occur. So that means what is the possibility that this event will occur. For example, we don't know whether the rain will fall or not. So it is a probability whether the rain will fall or not. A pregnant woman that is pregnant, you don't know whether she is giving birth to a single boy, single girl, a twin, boy, girl, or boy and girl. So these are examples of probability, and it ranges from 0 to 1. So if an event is certain that it will not occur, for example, now when you roll a single die, for those of us that play Ludo very well, when you roll a die, the probability of getting 7 is 0, because there is no face in a die that have 7. There is no face in a die that have 7. So the probability of getting 7 in a die is 0, because it cannot happen. You can say if it is impossible, certain, it is if an event is certain that it will occur, that is the probability is 1. And the sum of all probability of events in a sample space adds up to 1. So probability is the sum of all probability is equal to 1. So you cannot calculate probability and you have a value greater than 1. When you calculate a probability of something and your answer is greater than 1, then you should know that you have made mistakes. You've made mistake somewhere. You have to recalculate, because the sum of all probability is equal to 1. This is the formula for calculating probability. Favorable outcomes divided by the total number of outcomes. So calculating probability is number of favorable outcomes, that is number of required outcome, divided by the total number of outcomes. For example, now in a die, these are the number of faces that can occur. We can have 1, 2, 3, 4, 5, and 6. So the probability that 3 will show up, that means how many faces do we have that have 3, which is 1, and how many is the total is 6. So the probability of 3 occurring when we throw a die is 1/6. So we can use this formula, the event over the total outcome. So that is the formula for calculating probability. That is the formula for calculating probability. And let's move to basic probability concepts. Basic probability concepts. Number one, the sample space. the sample space. The sample space is the set of all possible outcomes in a trial. For example now, in throwing a die, a single dice, the total number of outcome is either we have one, we have two, we have three, we have four, we have five, or we have six showing up. So the set that contains all these possible outcome is called the sample space, and the sample point is one of the possible results. So in a set of the sample space of throwing a dice now, two is a sample point because it is one of the possible results in throwing a die. And again, in a deck of card, getting four of hearts is a sample point. We have 52 deck of cards. So four of hearts is one of the possible results in a sample point. Experiment or trial. Experiment means a series of actions where the outcomes are always uncertain. You don't know what will come out. You don't know what will happen at the end. You just do it. That is experiment. You just do it. And for example now, when you throw a die, you don't know the number that will come out. When you toss a coin, you don't know whether it is tail that will show up or it is head that will show up. So it is series of actions that you don't know what the result will be. You don't know the outcome of the action. So event is a single outcome of an experiment, and outcome means the possible result of a experiment. So when you throw a die once and you have the outcome is an outcome of the event. So for probability now, for a pregnant woman, when a pregnant woman give birth to a boy, so giving birth to a boy is the outcome of the results that the experiment that led to the pregnancy. So the outcome, whether it is a boy that the woman gave birth to, or a girl, or twin, or something like any other thing. So the next the next subtopic events and dependent events, independent events and dependent events. What do we mean by independent events, and what do we mean by dependent events? So two events are said to be independent if the occurrence of one does not, for example, when like you have two events are happening, and one of them is an independent event. For example now, when you are tossing a coin and you are rolling a die at the same time, the result of tossing a coin is different totally from the result of rolling a die. The result of tossing a coin is different totally from the result of rolling a die. So the outcome you will see is different. So it cannot affect each other. It cannot affect each other. But when two events are happening whereby the result will affect the result of this event will affect the other one. That means we have a dependent event there. So basically, independent events means two events happening whereby the two does not affect each other. They do not depend on each other. They do not depend on each other. But for dependent events, this event depends on each other. The outcome of one will affect the outcome of the other one. So let's move to the next one. The practical probability applications. So examples of real life probability applications. We can apply probability in weather planning. For example now, a probability forecast, an assessment of how likely an event can occur in terms of percentage and record the risks associated with weather. So for example now, if there are 40% chances of raining, then the weather condition is just that 40 out of 100 days it has rained. So for weather forecast, for people doing weather forecasting, that is meteorologist. So they use some instruments to predict weather changes. So let's say out of 100 days, the rain fell in 30 days out of 100 days. So the probability of rain falling next is 30%. So it is the instrument that will calculate the probability for the meteorologist. Meteorologist. So it is this instrument that will calculate it for them. And we can also apply probability in games. In games, gambling, sports. We don't know the result of it. For example, now when you are playing Ludo and when two dices are rolled simultaneously, this is the outcome table of this is the outcome table for rolling two die simultaneously. For example, now you can see this yellow list. It is speaking double six. So we have 36 different outcomes. These are the 36 different outcomes. So the probability of getting double six is out of 36 trials. Out of 36 trials, you can only have one chance out of 36 times trying it, and have one chance of getting six two times. So that is what this probability is talking about. And solving simple probability problems. For example, number one, the probability of a company launching a new product on time is 40%. What is the probability that the product will be launched late? So the probability of a company launching a new product early is 40%. What is the probability that the product will be launched late? So you should know this formula that the probability of an event happening is 1 minus the probability of the event not happening. For example now, the probability of, let's say the probability that a student will fail a test is 0.2, and you ask to find the probability that that student will pass the test, it is 1 minus 0.2, because the sum of probabilities, like I said earlier, is what? 1. So if you are given the probability of an event happening and they ask you that what is the probability that this thing will not happen, just subtract that probability from 1, then you have your answer. The probability of an event launching a new product on time is 40%, and 40% is 40 over 100, which um is 0.04. Is 0.4. 40%, 40 over 100 is 0.4. That is 4 over 10, 0.4. And the probability of them launching late is 1 minus 0.4. So if you subtract 0.4 from 1, you have 0.6. So the probability of them launching late is 0.6. So we'll be ending this stuff here. And this is your assignment. You are given a data set. Yeah, you are given a data set, and you have to represent the number of books sold in different types of so in different types. Represent this on a bar chart and histogram. So you are asked to represent this this data sets on a bar chart and also on a histogram. So that is your assignment. Later I will give the procedure on how to submit the assignment later, but just know that this is the assignment that you have. So if you have any question, you can ask. If you have any question, you can ask. You can unmute your mics and ask.
Can you hear me, sir? Good
Yes,
evening,
I
sir.
can hear you. I can hear you. Good
Good evening,
evening.
sir. Thank you so much for this lecture, for this class. May
Amen.
the good Lord bless you. Everything you said is well understood. I don't really have questions. Please, are you going to help us send their assignments to the WhatsApp group?
Yeah, the slide is already on the WhatsApp group, and the assignment is on the last slide.
All right, sir. Thank you very much.
The assignment is on the last slide. So, any other question? Anybody else? Anybody having questions? So, you can also study the slide again to understand it very well. And if you have any question, you can um, you can drop it on the group chat. So we'll meet again on we'll meet on Tuesday. Yeah, we'll meet on Tuesday. We'll meet on Tuesday for another session. So thank you all for joining. We'll be ending the class here.